Hello, this is my brushless DC motor turned into brushed DC motor. Let's take a closer look. This right here is the commutator. These two are the brushes. This is the shaft, this is the BLDC. The BLDC is salvaged off of a washing machine. It's an LG washing machine. The shaft right here is comprised of two parts, one being the original shaft and it ends right about here, and the other is this additional shaft which goes all the way to here. The original shaft was too short for this project, that's why I needed the additional shaft in order to lengthen the original shaft. The way I joined the two together is the following. Firstly, I've made a threaded pole on the original shaft. Then I've made a threaded hole in the additional shaft. After that, I've made facets at an angle where the threads were. Then I screwed the two shafts together, thus creating a V-shaped space where the two met. After that, I filled this V-shaped space with material by welding and finally turned everything on a lathe to make it look like a one continuous piece as it does. Next, the commutator, right here, is built around a PVC water pipe with a diameter of roughly 120 millimeters or roughly 5 inches. And this is woven commutator, meaning that all of these individual pieces of wire that you see here protruding are in fact segments of a much longer wire running beneath the surface of the pipe. In total, there are 6 wires arranged around the perimeter of the pipe. 3 of the wires are woven on this side and 3 of the wires are woven on this side. After carefully analyzing the commutational table for a BLDC, I realized that I needed to separate the negative side and the positive side of the power supply to the motor if I wanted to achieve success. Furthermore, the commutational table states the 6 combinations for a 6-step commutation for a BLDC. The first combination states that the positive pole of the power supply must be applied to the first phase and the negative pole of the power supply must be applied to the second phase. In my case, this is the first phase, this is the second phase, and the black one is the third phase. The second combination in the commutational table for a BLDC states that the positive pole of the power supply must be kept again in contact with the first phase, but now the negative pole of the power supply must be kept in contact with the third phase. So, somewhere around here, around the perimeter of the pipe, on the positive side, as the combinational table states, one of these wires is connected to the first phase, the green phase. The next wire, right next to it, is again connected to this green phase. Exactly across them, one of these wires is connected to the yellow phase, the next wire is connected to the black phase. And the remaining of the wires emerge somewhere around the next spot on the perimeter of the table or of the pipe, as the commutational table states. Yes, and the way these two brushes are mounted on the commutator is such that they are always one step ahead of the actual position of the rotor, meaning that when the rotor is aligned with the field produced, let's say, by energizing the first and the second phase, at that very moment, these two brushes here will move on to the second combination in the commutational table, thus creating a revolving magnetic field, which is always one step ahead of the actual position of the rotor. That's how a revolving magnetic field is created, which is chased by the rotor, because the rotor wants to align itself with it. Right now we will power this thing up. This is my power supply, it's 24 volts DC. So 1, 2, 3. Now I'm going to turn this thing off. That's all. Thank you for watching.